请起充话筒。
Testing. All right, let's start. So later I will show you an example on how you submit your videos. And there's some errata from last week. If you notice that this E question here, the solution is very weird. Because we have like the unit of 100, around 100 here. 0.013. So basically, there's something wrong with this E to the minus X to the 10% here. So basically, to find the T, I should take log instead of dividing. Because I think there's a wrong way of writing T here, so I thought it's a scalar. But actually, you have to take a log here. So if you look at the lecture note that I posted up last week, right? So there's an answer that makes more sense here. And this number changes because, like how you point out last week, right? We use the wrong multiplication instead of division. So these answers make more sense now. And then some picture, nice picture shown by the textbook, show how the growth of this logistic model. Any question on this one so far? Have you checked out the lecture notes? Okay, so it's not a scalar because we treat this as a scalar last time. Actually, you need to get long to find the search. Okay, this one is for this. And the other one, if you still remember this question here, this mixing problem here. Okay, so last time we used the maximum sort that could get to throw out some possibilities here. But there's one way to do it without looking at the physical condition. Okay, although physical condition is very important, but if you look at this equation here, so last time we were looking at this equation, right? So we are deciding whether we want to take a positive or negative of 150 minus y, right? So we are wondering we want to take positive or negative. Okay. But the point here is if you look at this modulus here, the right hand side is always positive. Okay, so what does this mean here? So meaning you can't know anything yet actually, because this modulus will turn negative into positive anyway. But the point here is where we start is pretty important. Okay, where we start. Yes. So if you look at where we start, right, this difference here is positive actually. Okay, so you actually start with a positive difference. Then your after taking modulus still positive. Okay, so meaning you have to stay on the positive side because our function has to be continuous. They cannot jump to the negative and then positive or anything like that. Okay, so let's say your starting point is 160, then this term will become negative. So maybe you want to choose the negative side. Then because your difference, yeah, because you need to stay with this continuity condition. I will assume that our solution is good. Does it make sense? Okay. So really depending on this initial condition. Okay, any question? So these are the two questions we met last time, I think. Yeah. So if you plot out this logistic model, right, this exactly matches up with what we said last time. So the maximum sort you can get is here. Okay. Yeah, any question for previous lecture or the course in general or final exam or quiz? Hey, some of you didn't hand in quiz. Not sure why. Why didn't you submit quiz? Let me submit. There's a quiz on Monday. Oh, you forgot. This is the last quiz, huh? Oh, your air condition got problem. I see. Okay. Oh, I see. I see. I see. I see. Okay. Yeah. Yeah. Um. Right. Any questions so far? But I think for those who handle it, pretty good. Yeah. I think at least 15 and above all of you, I think. Is it easier this time, the quiz? Easier. Straightforward. Yeah. All right. If not, we will continue then. We'll see how it goes and then we'll see what we should do on Friday. But definitely Friday we'll discuss quiz. Okay. Right. Let's continue with the last section here. Section. So we'll deal with first order differential equation. Okay. So first order meaning you only have one first derivative. First order derivative here. So the derivative is order one particle. So order one maybe it looks like this. Okay. Again, it's called linear if it get put into the form of the following dy over dx plus pxy equals to qx. So the linear part refer to this y to the power 1. Okay, so let's look at this example here. So in this case here, we see that it's linear because there's only first order derivative here. And then the power of y is also power 1. Okay, so this is a linear first. Okay, I should have called it this. When I say linear first order differential equation, first order linear, maybe it sounds better first. Linear first order differential equation. Maybe make it linear first equation. Okay, so how do we solve this? So there's a technique to do this, but but let's think about it. Okay, maybe we can try and play around with it. Uh, y plus 1 over x y equals 2. Actually, we have to give a extra condition, right? Because we are dividing by x, so actually we should let x not equal to 0. Okay. But then we can rearrange this to xy prime plus y equals 2x like this. Okay. So if writing up to this stage, right, do you have any idea on how to solve y? You have any idea of how to solve one? Maybe look at this term here. Does this term look familiar or not? You have a derivative here, and then here doesn't have a derivative, but x disappear. You differentiate one side, differentiate the other side. What is it? Product rule, yes. Okay, so you can use product rules to turn this to xy, right, equals to 2x. So yeah, right. Okay, so you differentiate y, and then plus you differentiate x. Right. Okay. Then from here, what can you do? From here, then we can integrate both sides. We can integrate both sides. Such that we get xy equals to x squared plus c. Or we get y equals to x plus c. Because the antiderivative of xy prime is just xy. Okay, so far, can follow? Okay. Okay. So one thing I want you to observe here is you multiply a function across this differential equation, and it turns out that you can use product rule to solve it. Okay, so this is the technique we're gonna use in this section here. Okay, we're gonna use in this section. Right. Let me see. So actually, what's the role of this x? Let me see. How should I put this to you? Yeah. Let's see. Okay. Wait. Let me see. How should I introduce this to you? Okay. So what's this x here? Actually, this is what we call the integrating factors here. Ix equals to e to the integral of px dx here. I think we don't need to care about this for the moment. Okay, so this is how we determine what we want to multiply here. Should we try it? We tried it. So let's try this first. Then we'll see why it works. Okay, so maybe we rewrite. Right. Example 5.10. Okay. So let's see how it works here. Let me see. Maybe I should write a little bit more. Let me see. How should I put it? Okay, so this is the technique we had here. So this, if we set I equal this to this integrating factor, then we will solve y as 1 over ix, integrating ix qx. Okay, so what are we trying to say here? So let me tell you how to read this formula, and then later we'll see how this formula works, and then I will try derive for you also. Okay, so well, why are we looking at this kind of linear order, first order differential equation? Is it is determined by this px and qx, and the solution can be written in px and q. Okay, so first, you need to use your px to find this integrating factor here. Okay, and then your solution will be in terms of integrating factor with qx. This is the solution. Okay. So this solution is how we can get this, for example, y equals to x plus c over x here. Okay, does it make sense for now? Okay, I'll teach you this method first. Let's see I can derive for you or not later. Okay, so let's use this method here, y equals this, to prove that we also can get this solution. Okay, so this is the goal. Anyone got problem? No? Okay. So we'll bypass this products rule and then we will use this formula. And then later I will try to use I will use the derivation to prove to you that actually after taking product rules, this is the general formula. Okay, so let's try this formula here. So let's find out what is our px. So our px here is 1 over x, and our qx is 2. Wait, let me check. Yeah, correct. Okay, so make sure you write on the right, the correct side. So then, what is my ix here? And the integrating factor ix is just equals to e to the integral of 1 over x dx, okay, which is equals to e to the log x. So far, okay, log x. Then you just get x. Okay, but so using the formula y equals to 1 over ix, integral of ix qx dx just become over x integral of 2 over x. Is it correct? Let me see. Ix, ix times, okay, so it's 2x dx. Okay, but then what is the integral of 2x? Become x squared plus e, which is uh, x plus c over x. Okay, so you might think that why it works, how it works. Okay, so we get the same answer about why it works. Yeah. Are you interested? Why it works? Huh? You guys interested why it works? Or you are happy with this formula? You happy? Madia is happy. Anyone know why it works? Or you are happy? You want to know how it get derived? Yeah. But wait, so first question is, are you okay with this formula? This formula okay or not? If I give you first order linear equation, you can find px, you can find qx, and then you can find this ix Once you can find ix, you can find your y. That's it. Yeah. But you want to know why it works? No. Anyone know? Anyone got question? Yuhan, you know what I'm saying? What do you think? Huh? Nothing. You just accept. You know what I'm saying? Oh, that's also. Huh? It's also. Sorry? Jiang. Okay. I don't think. So he wanted to know. Okay, so maybe let's try and see why how we get this solution. How we uh come up with this integrating factors. Okay. So maybe let's spend some time deriving it. Okay. So we want to get it into a form of product rule. So we will assume that Ix is the thing that you multiply into the left-hand side of your first order linear differential equation, linear first order linear equation, such that you get this product rule condition. Okay, you assume this is true. Then we also know that this Ixy prime here actually equals to something in Qx. Still remember? Just now I multiply x across. Okay, so if you remember here, this part here, I write to product rule on the left hand side, and then the right hand side, the q here, multiplied by the ix. Okay, and then from here, then we can solve by product rule again, like what Pington said just now, right? So no product rule. It's just the integration on both sides. Then we will get Ixy equals to the integral of Ixqx dx plus. So this is the final answer we'll get just now. Okay, good. But the problem here is what is Ix? Okay, how to find this Ix? Does Ix always exist or not? Okay, this is the problem. Does Ix always exist? Okay, if it exists, how should we find it? Okay, the problem is how should we find it? Well, how do we find it? Maybe we can start from the first line here. Okay, maybe start from the first line here. Let's see how to find it. So I get Ix y prime plus Ix dx y, and then on the other side I have I prime x y plus Ix. Okay, so if you notice that there are similar term on both sides, such that we left with Ix px equals to I prime x. Okay, so from here, do we know how to solve this yet? Do you know how to solve this? Yeah, do we know how to solve this? Or how about, let me write in this form. How to solve this? Or maybe just I write in this form. You know how to solve this? That's why I write in terms of x. Substitution rule. Oh, right hand side. Ah, substitution. Ah. Yeah. No need, right? So this is just a separable equation. So you just integrate both sides. Like this. Okay. So what you get is um what you get is ln on 1 for I equals to the integral of dx, and then I will be equals to let's say, yeah, so there's a constant e to the integral of px. So this we can take a equals to 1. It works. So this is how we get the I. Okay or not? Does it make sense? Does it make sense? Okay. So actually we prove that this I here will always work as long as your px is integrable. As long as you can find the inter you can find the integral of px, then this I will always work. Okay. Any question so far? Any question? Okay. So if you are happy, then you can take this formula. Okay. So you need to determine what's your px, determine what's your qx, find your I, find your y. Okay, find your I, find your y. All right. So let's look at this question here. Maybe I give you 2 minutes to try and find what is p, what is q, and then try and solve what's your y. So this is a perfectly good first order linear equation here because it just involves dy dx, and then there's only y to the power 1 is involved. So try and find your p and q. Okay. So what's your px here? Hmm. What's your px? Jose, what's your px? Your px? X square. Good. And then you can find your ix. Ix will be equals to e to the integral of 3x squared dx here, such that you get e to the x cubed. Okay, you might think that why we don't have a plus c here, because if you add in a constant here, is the constant will disappear later. And so we won't care about the constant. Then next, what's your qx? Qx will be 6x squared. Okay, then we will use our formula. Yx equals to 1 yx integral of yx qx dx. Okay, so we'll put a bunch of things inside here. Hmm. Okay, see here. So we get 1 over e to the x cube, integral of e to the x cube, and then qx is 6x squared dx like that. Okay. How to do this integration? By part. I think there's an easier way. Substitution. Okay. So just substitute x cube, x cube equals 3x squared dx. In the quiz, a lot of you, after doing substitution, right, you didn't substitute back. Okay, make sure you substitute back after you do substitution, because our function is in term in x. E, yeah, 2e to the 3 c, which is equals to 2 plus e over e to the x cube. Okay, straightforward. Question? Any question? Any question from there? 这个怕干你. Yeah, any question? Okay. All right. How about let's do one more? So here we're gonna find solution to the initial value problem. X greater than 0, y1 equals to 2. Okay, so you could imagine that we kind of fixing constant now. Okay, because when we evaluate at 1, we want to get 2. Okay, so let's try this. Give you another 2 minutes. Yeah, try try in class, and now you got time. Please try. Yeah, what do you get? Hmm. Ln x over x. Okay, and then yeah, I don't think it is so complicated. Hmm? Yeah, have you written in your PX form, QX form? So how to see this as a first order linear? So as x is always greater than 0, right? So we can simply divide the x across. Okay, so then your px will be 1 over x again. Qx will be 1 over x squared. So then what's your I? Your I is e to the integral of px, which is e to the ln modulus x, but x is always greater than 0, so this is just x. Okay, then what's your solution? Y, which is 1 over ix, integral of ix, qx, dx. Okay, so 1 over x, integral of x times 1 over x squared. Ah, I see. I got mistake my calculation. Okay. So please check out whether this is correct or not. Dx, which is 1 over x, integral of 1 over x dx. Yeah, I think you get ln, which is equals to ln x, because x is always positive, over x plus c over x, like that. Yeah. Is that what you get? 金姐? Yeah. But we are not done yet, right? Because we got this initial value problem here. So since y1 equals to 2, so meaning 2 equals to y1, which is ln 1 over 1 plus c over 1, which implies that c actually is 2. So y equals to ln x over x plus 2 over, like that. This one is x. Okay. Question? Any question? No question? Question? Okay, if not, let's continue with the next one. Okay, give you some time to try it out first. Set your px, set your q, and then try and find what's ix, and then try and find what's y. Okay, anyone back problem in integration or not? Let's see. Let's see. Okay, so let's try. So our px is 2x, and then from here we can get what is ix, which is e to the integral of px dx. Then we get e to the x squared. Next, we need to get what is our qx, which is 1. Then yx will become 1 over e to the x squared. The integral of e to the x squared is plus. Should we have a plus c here? No, right? But then, yeah, let me check. Okay, but then what? Then, do you know how to integrate this? I think we never learned this in class, and I don't think we can use any method we learned here. Okay, so this is the answer. Then you can just stop it. Okay. Yeah. Because so far using the machinery here, you cannot do this. Unless you got a X here, you can do substitution or by part also can. Otherwise, you cannot do this. But in calculus, you can do this. Calculus next semester. Okay. Yeah. Any questions so far? Yeah. Any questions so far? Mhm. Oh, I think we missed something from our formula, right? Let me check. Did we miss something from our formula? Let me check. Did we left something from our formula here? Oh, I think we are missing something in this formula. Okay, I think it's better to plus a c here. And so that here you actually got a c over 1 over x. Okay, and then if like that, maybe here we need to plus a c, and then here we got a c over ix. But then they will combine together, they will get combined. So maybe it's just another constant. Okay. Yeah. I think it's better to plus a c here because this is the most general form. Okay, so here, let's plus a C here. Plus a C. But in general, it doesn't matter, right? Because you are just changing another constant. Yeah. Yeah. Maybe you can plus a C here, then plus a C here. Then this one change to another constant. And then here we got an extra C. Okay. Any questions so far? Any question? Any question? Yeah. Any question so far? Any question? Yeah, I think the notes got a little bit problem. You need to pass a C there. Because you see, if you look at our derivation here, actually we got a C. Maybe we can oh, maybe I read C over C is in real number. Okay, any question so far? Question? Okay. How your project goes? Start recording already? Ready? Yeah. For your projects, right? Maybe I will upload a SM drive link later. You can upload your video into it. Okay, your group leader can upload into it. And at the same time, I want you to provide a link that you upload as well. Okay, so maybe you can do both. Yeah, so when you upload the PPT right into the link that I created, you see the link I created in Moodle. Let me show you. Hey, I haven't create maybe I'll create later. So I'll create a link like this, like the submission link, right? Quiz. This is quiz for submission, but I'll create a PPT submission. Okay, later you submit there. Just the leader submit is enough. Okay, leader submit is enough. And people are asking me about your group number, right? If you look at this presentation format here, I already list down all your group. Okay, you can check. I think someone haven't told me the leader yet, no? And even question, is Roshi group already got? Where's Roshi? Is your topic fixed already? What's your topic? Number 2. Okay. And I think there's a leader haven't fixed yet. Where's the leader group? Yeah, this group. Group 11, who is the leader? Oh, Wenqi. Okay, good. So just the leader will submit the PPT. Later I will set up. And then instead of PPT, what you do is, let me show you an example from your classmate here, which is from Chen Fan. So your PPT, right? Yeah, it's your. Yeah, so if you look at this PPT, you can put your video link here, okay, so that I can access it. Make sure I can access it. Yeah, let me show a little bit. I won't show the full thing, but okay. And yeah, show your face. Show your face, show your content. Clear? And you again
step by step. And the number three, output, and the loop breaks when the
okay. Show your face, show your content. And then I will also at the same time give a SM drive link, and you can upload your video there also directly. Okay, so give me a link, give me your file as well. Is it clear? Okay, just the leader, you need to do this. Make sure you name your file correctly. What's your group? What's your topic? Okay, so that I can check whose file is that. Because a lot of you have the same topics. So group number is very important to differentiate your video. Okay or not? Yeah, so group number is very important because your topic can repeat. Okay, so you put your group number, put your topics. Okay, otherwise I cannot differentiate which group is which. Is it clear? Okay, especially the leaders, please take note. Yeah, and then put your link on your PPT that you submit. Okay, so that when I go through your PPT, then I can go to your video as well. Question? Any question? Know how to submit? Know what to do? Okay, especially the leaders. Leaders must take notes because you're gonna submit all these things on Friday, right? Okay, yeah. Mm. Okay, maybe if no question, we'll take a break and then we'll come back again. Let's break until 11:07. Okay, let's take some attendance. Yeah, Ting. Yeah, Fen Fan. Wei Ye. Wei Ye, I think not here. Hong Liang. Xi He. Yeah, Le Tian. Le Tian here. No? Chen Le Tian. Okay. 瑞阳。若是诗曼。意南。玉涛。玉涛 here 了。玉涛。玉涛 here。一则。丽文。got 瑞阳。Yes. 泽汉。Yeah. 加来。加成 got 加一 got 齐军。黄齐军 OK。易清 Yes。相思 got 一零雷一零 here 了。not here。季俊义呢 ？Is 季俊义 here？俊义 not here。冰珍 here。加坦呢？加坦 Hello 加坦 Why you not submitting the quiz? You forgot. Okay. 浩云。文琪。汉翔。汉翔呀。俊杰 got 新阳。Yeah. 万达 I think got 新月。玉恒。益田。冰城 here 了。冰城 OK。浩然。冰城有时候 didn't submit your quiz. No. No. You don't do quiz. Did you know there's a quiz? No, no. Okay, you missed the deadline yesterday. Desmond not here. Tommy got. Chong-yi got. Inje got. Pagani here. Arthur here. Jose here. Hisham. Hisham here, right? Okay. Daniel not here. Hashim, being Yusuf Hashim, not here. Adia got Aaron, Brandon, Felicia, Gunagati. Is Gunagati here? Margaret, Javed, Gabriel. Yep, Gabriel, yeah. Jeffrey got Purity, don't have.
You felt I was like behind the thought
I told you attendance.
yeah, I
Yeah.
thought you said like senior still.
What?
I thought you said
Oh, I said Purity was not. Yeah. Yeah, I took 3 of you. Hey, what's your deadline? Submission deadline. Second, 2nd January, 5 p.m. Okay. Huh?
yeah, Lucas.
Yeah. Yeah. Something got problem.
I think
Mm.
I mean
Mm.
yes,
Mm.
the road
Mm,
both
mm,
side
mm,
and then it's a substitute.
Content integration just is a substitution rule. Where?
Because
Mhm,
actually
mhm, mhm,
you improve by dx.
mhm.
So six dx.
Mhm.
And yeah, so
Oh yeah, sure. Okay, you mean the I? You mean I? Is it?
yeah,
Yeah. I think
so
it
it's
makes
to be
sense.
a substitute.
Yeah, makes sense. So we make when we do this stuff.
Yeah.
Yeah, sure. Makes sense.
Yeah.
Okay, thank you. Okay, now I have upload. I mean, I have set up the link now, so you can submit your PPT with your video link inside your PPT here, and you can submit your video as well. So both, submit both, so that I can have access to them. And if you open up this link, right, this is the SM Drive link. So name your group also, and then name your topic. Okay. So group is very important because there will be same topics. So use group to differentiate you. Okay, so you just upload your video here. Okay, any more question on how to submit? Not clear? Okay, I think we have one last question to do for this section here. Okay, let's do this again, a mixing problem. Okay, let's try this mixing problem. So a tank have 100 liter of water, and then again a solution with salt concentration 0.4 kg per liter is added. The rate of 5 liter per minute. Sorry. The solution is kept mixed and drained from the tank at the rate of 3 liter per minute. Let YT be the amount of salt after 10 minutes. Very similar question that we had before. But then what do we have before actually? Let's see. Oh, we had the exponential growth formula. Is it? Let me see. Yeah, we also actually have a first order uh, equation before. But then here we have a more complicated. Okay, previously there was just constant in front of y. Now we got a variable t here. Okay, let's see how we get this. Let's see how we get it. All right. So first of all, what is y0? So meaning what's the zeroth minute amount of salt? Well, so how should we take this? Y is the amount of salt, and then what is y0? Does it say anything or not? What do you think? What is y0? Is there any salt there? No salt, huh? Okay, I think y0 is just 0. It didn't mention anything, right? It just says that this tank has 100 liter of water. So there's nothing here. Okay, then we're going to show this change of rate of amount of salt going in and out. So again, we'll use the same formula. dy dt is equals to the rate in minus rate out. Okay. So what's rate in? Okay. So how much does it come in? So this is straightforward. It says that 0.4 kg per liter add in the rate of 5 liter per minute. Okay, so that dy dt is in terms of kg over minute. How about rate out? Okay, how about rate out here? So rate out is different, right? You can see that the rate of going out is become slower. But it also depends on what is already inside your tank. So what should we do? So we need to decide what's the amount of salt, what's the density of salt actually. Okay, rate out, I mean like in terms of liter we know, but how about in terms of density? Okay. So we need to decide what's internal density. So here's the trick that we need. Well, definitely your amount of salt will change in time. Okay, so YT. But How about your water? How does your water change? Okay, how does your water change? Okay, how your water change is very important here. Here top is kg, and then how about your water? Your water start with 100 liter, okay? But then how does it increase? Okay, how it increase? So it increased by 5 minus 3 times t. Okay, rate in minus rate out times t. Is it okay or not? Okay. Yeah. So do you expect that your water will increase because the rate in is greater than rate out? Okay, so your water is increasing. Okay, 5 minus 3 over time t. So altogether, what do you get? 2 minus 3y over 100 plus 2t. Exactly what we wanted to show. Okay, so far. So why I keep this unit to make sure you know what number are you calculating here. Okay, to make sure how to put this number together. Okay, why this number makes sense so far. Okay, question? Got question? Or should I add another unit for your rate in and rate out so that you really get liter from here? So rate in minus rate out can times you like with liter. Okay, so far. Question? Okay. Yeah, no question. Then the next step you should expect that we ask you to solve it. Okay, solve the differential equation in B with the initial condition in A. So, well, in this case here, is this a first order linear equation? Okay, it is because you're only dealing with dy over dt, first derivative. And then there's a pt here, okay, beside this y to the power 1. And then there's a qx here, qt here. Okay, so let's write out what we have. Note that dy over dt plus 3y over 100 plus 2t equals to 2. Okay, so we have our pt, which is 3 over 100 plus 2t. In that case, our it here will become e to the integral of 3 over 100 plus 2t dt. So to do this, you just use substitution. Okay, just use substitution. And then you get e to the 3 over 2 ln of 100 plus 2t, like that. Okay, but if you notice that the absolute value here doesn't really matter because our t is time is always positive, so this guy here is always positive. So we were just left with 100 plus 2t to the power 3 over 2 because t, right? Okay, so this is it. How about your solution? So since qt equals to 2, so yt will become 100 plus 2t to the minus 3 over 2, and then integral of ix time it time pt, sorry, it time qt, yeah. So qt is 2, then time 100 plus 2t to the 3 over 2. Let's see. Okay. And then is it easy to calculate here? Again, you use substitution. Okay, you use substitution here. So if you use substitution, I guess what do you get? You will get okay, so maybe let's move out a little bit. You get 100 plus 2t to the power minus 3 over 2, and then you will get 2 over 5, 100 plus 2t 5 over 2 plus c, and then altogether you get 2 over 5 of 100 plus 2t plus c over 100 plus 2t to the minus 3 over 2. Okay, so far. Question? No question? Should I show you this? This one substitution? And let u equals to 100 plus 2t. So du equals to 2 dt. So that's why this 2 get absorbed. And then you plus 1 to the degree and then divide by the new degree. Any question? Can follow? If cannot follow, please let me know. And we got plenty of time. Question? Okay. Pingzhen, okay. Okay. So let's continue. Then we need to figure out what's this c. Okay, so what's this c? So since we know that y0 equals 0, in that case here 0 equals to 2 over 5 of 100 plus c over 100. So here already moved down, right? So no need negative. So just 3 over 2. So what's c then? 40 plus square root 10, 100, 1000, c to the 1000. Yep. And then c will be just equals to minus, is it minus? Minus 40 divided by 1000, so 0.04123. Let's see is 0.04. If you like, maybe it's minus minus 1 over 25. Yeah. So our y t would be yt would be yt would be 2 over 5 times 100 plus 2t plus, sorry, minus 1 over 25, like that, of 100 plus 2t. Okay. Okay, so far, any questions so far? Any questions so far? Oh, good. Any questions so far? Feel free to stop. Yeah. Okay. So next is to find the concentration, okay, after 20 minutes. Okay, let's find the concentration after 20 minutes. So I think concentration here means the density, right? You need the amount of salt versus your water. Okay, so let's find the amount of salt first. So we have this formula, right? So let's continue with this formula. So D part D, we want to find Y20. What is Y20 here? Okay, so basically you just substitute your 20 into your T. Okay, so what is it? Right. Uh, what's the cube root of 140 and then square root. Anyone get this? What's this? What's this part here? Anyone compute this? What's the second term here? What's this term here? Any idea? What's this term? Any idea? What's this term? Can someone try and click your calculator? Any idea? What's the term? Hmm? Yeah? What's this term? Anyone? Hello, hello. Calling. What's this term? I think you stay on it also no use. I think 140. Well, I mean like sorry. Huh? Close to zero? You sure? So small. This term, what's this term? Close to zero. Oh, seems like close to zero. Wait. Oh, almost 56. How close to zero? Can I see? Huh? How small? You tell me. 2.4 or 0. How many decimals? 2 times 10 to the something. How many? So small, man. Did we make any mistake or not? Huh? 2.4 times 10 to the negative 8. 5. Negative 5. Did we make mistake or not? Hopefully we don't. Let me see. Sometimes if the answer looks weird, maybe we make mistake. I don't think so, right? Square root become 10 and then 10 cube 1000. I think we make mistake, right? Again, it's the stupid mistake. Is it stupid mistake here? This part. So I move 4040 on the other side, right? I should multiply by 1000. So this one is wrong. So here you get minus 4 t and then multiply by 1000. I think this is the correct unit here. So I should put a 400,000. Okay. Sometimes if the solution looks weird, you need to check your step. I think here is wrong. Yeah, so this part wrong as well. So it should be 400,000. Yeah, 400,000. Okay, how about now, Felicia? Does this make more sense now? Click this number again. 400,000 over cube of 140 and then take square root. What's this? Huh? 400,000 divide by 140 and then to the power 3 over 2. How about this? Huh? What? 200? 200? You sure? Then isn't it something wrong here? Very wrong. Do I have calculator with me? Maybe I ask Apple to do it. Wow, even wrong. Yeah. Over. Oh, 200 oh. Become negative? What's wrong here? Let's see. This minus sign looks very suspicious. Are we doing the right thing? Did we miss any sign? Huh? This minus sign looks very suspicious. YT is the amount of salt after a solution is added. At the start, there's no salt, right? I think it's correct. Any idea? Any idea what's wrong? Did I miss anything? Why is 0 equal 0? What's wrong? So it seems like this cube is not big enough for. What's this graph here? Can I ask this Apple to plot this graph for us? Y equals to 2 over 500 plus 2 cube. Let's say thousands. Oh, I think too many zero, right? 1, 2, 3, 4. Only 4 zero here. So here 1, 2, 3, 4. Okay. So we got an extra 0. Yeah, I think this makes more sense now. So it should be 24.15. Okay, good. 24.15. Okay, I think we got it. So it should be 24.15. Okay, Felicia, we got too many zero. It's just 40,000, not 400,000. Okay, so then we will get something like 85.85 and then 21. Okay, so this is the amount of salt we got. Okay, how about the concentration? How to figure out concentration? Meaning the density. Can you figure out the water that goes in or not? Still remember just now how we get the water, the volume of water after 20 minutes. Okay, how do we figure out this? This is just 100 liter plus 5 minus 3 times 20. Okay, which is 140. Okay, 140 liter. So the concentration of salt after 20 minutes equals to 21.85 over 140. So what is it? 21.85 over 140 equals to 0.156 kg per liter. Okay. Any questions so far? Question? Be careful with this decimal place in this topic. Careful. Otherwise, you will come out with some tiny number that doesn't make sense. Sometimes maybe it is the real situation, but make sure that your calculation has no error. Okay. Yeah, your arithmetic. Any questions so far? Question? Is it clear? Feel free to ask. How your other course go? You already finished teaching or not? Or still on syllabus? Finish. Linear algebra finish. When do you guys finish? Oh, yesterday. So do you still have class? No?
No.
Or just my class? I also left with your class. Last day. Do we cancel it? No, just kidding. Huh?
Let's cancel.
Cancel it? I think we still got quiz. We can finish earlier, but we can't cancel it. Or do you want to start late on Friday? You want to finish earlier or you want to start late? Or you want to finish? Okay, then.
Who
Huh?
study
Sorry?
in second
Huh?
January? Who study in 2nd January?
Who knows? Who knows? Yeah. I think on Friday we will discuss about quiz and then we will do revision a little bit and then see how much you want to do. You can bring your question. Otherwise, we have a revision set for you in Moodle. You can try that out. Yeah. Maybe we can pick a few and then discuss in class. And if you have any requests on lecture that you want to repeat, you want me to repeat, we can do it as well. Yeah. Otherwise, the main agenda is quiz 4, and then the result of quiz 4, and then revision set. Yeah. You can have some requests on my lectures, notes, or textbook question, anything related to Congress. And maybe on the last day we can take a group photo. Yeah, okay. Okay, how do you find this course so far? Is it hard? Hard. Very hard. Please just say very hard. How about the rest then? Can keep up? Can follow? Cannot? Jai say cannot. Yeah. I mean, like, feel free to ask. You can post question in Moodle. You can message me or email me directly. So please take the opportunity to approach your lecturer. Linear algebra harder or calculus is harder? Calculus harder. Okay. You spend more time with calculus, 5 hours. So the content is like almost double. But for the finals, you will focus mainly after the material after midterm. Okay. Yeah. But as you realize that when you do integration, right, sometimes you need differentiation. Okay, you cannot say that you don't want to know anything about differentiation because even if you do by parts, do substitution, anything else, you still need differentiation. Moreover, this differential equation you also need differentiation. Right. So yeah. So you need to revise a bit, but mainly will be after the content will be after the tested content will be after integration stuff, differentiation, differential equation. Any question? No. No. Okay. Happy. One thing I want to remind you as well is after grading your quiz, right? I think a lot of you, few of you have careless mistake always, because I think I expect you know how to do, but somehow you forget to change back your substitution, or you forget the plus C. Remember the plus C when you do the integration? If it's not definite, you need a plus a constant, and yeah, so there's a lot of careless mistake. Also with arithmetic, when you combine coefficient, combine constant, you make mistake. So please be careful with your calculation. You know how to do, but your calculation have mistake. Okay, so that's very unworthy. Okay, so please be careful with your calculation. Other than that, I think it's okay. Yeah. But I think after I mark your quiz score, right? Whoever did the quiz score, I think you get 15 and above. Yeah. So it proved that actually you are still learning stuff, I guess. Yeah. At least you are learning stuff. You cannot just simply guess and then guess the answer. You have steps. So I hope that you will keep learning, keep improving. Okay. This will be very useful when you go to later years. Okay, because when you move to later years, right, the material will only get harder and harder. So you need to have an ability to study of yourself. You need to measure your progress. You need to be able to measure your progress. Okay, any question? If not, we can break earlier today and then we will meet you on Friday. Okay, please bring revision question. Submit. Sorry, it's closed. Yeah. Yes.
Group assignments.
Group assignment, yeah.
Here for the formula,
That is from the